Hello, hello from a wonderful, beautiful, snowy day here in Mammoth Lakes. For those of you guys who are not from Mammoth, we've gotten probably 2.5 feet of snow since last night, and a whole lot more is coming down. It just will not stop. It is relentless, and we're supposed to be getting possible 2.5 feet today, another possible foot and a half tonight. Just a lot of snow coming down, so I'm thankful I'm inside. The ears for today. These are the Haunted Mansion main attraction ears. So it's Madame Leota. We've got some sparkles, and it's like supposed to be the bride from the ride. And they've got this veil. Where's the veil? They got this veil thing back here and ribbons, and it's just fun. It's kind of cool because these are our school colors. School colors, teal, purple, and black. So I just thought it was kind of cool. So I should wear them. Anyways, here we go. Chapter 7. We are starting polynomials, which happens to be my all-time favorite. I don't know what it is about polynomials, but I just love teaching this material. And before we get going on the lesson, there is about 7 vocab terms that I need to get through. And so I wrote them all out. And so what you're going to have to do at home is just pause and hit pause and hit pause. Because polynomials, kind of like functions, has a really diverse vocabulary. There are words that only apply to polynomials, and the big difference about polynomials versus functions is these words show up in the directions. So if you don't get the vocab down, then you're not going to quite know what to do with the problem. But the good thing is, have no fear, the vocab is pretty easy to get down quickly and have it in your head already. So here we go. 7.1, polynomials. First thing I'm going to do is define a polynomial. It's a monomial, or sum of monomials. Okay. So examples, -5. X minus 4, x squared plus 5x plus 6, and 2xy squared. These are all polynomials. So if you want to think about it, hit pause. Polynomials is like the big family. Okay? We're going to be learning about polynomials, and underneath that are more specific polynomials. So it's kind of like saying the category of fruit. You have fruit, and then bananas and apples and strawberries, that kind of thing. Well, we have polynomials. And underneath that, then we have the apples and bananas and that kind of a thing. These are all examples of polynomials. More specifically, you can have a monomial, which can be a number, variable, or product of a number or one or more variables. These are also known as one terms, okay? So a term is in a polynomial. That would be a one term. This is a two term. X is one term, and then -4 is the other term. So in monomial, here are some examples. 16. So we could have been calling these monomials a long time ago, but it was a little bit above your heads. W is a monomial. But then also this big thing right here, -3xyz to the second, is also a monomial. So a monomial is one term. There are no addition or subtractions in them. If anything, it's just multiplication. Next up, binomial. So if you know your prefixes, poly meaning many, mono meaning one, bi meaning two. So a binomial is a two-term polynomial. Example, x plus 2, x squared minus 4. So in here, x is one term, and then positive 2 is the other term. X squared is one term, and -4 is the second term. Remember, terms are separated by addition and subtraction as a reminder. Then comes a trinomial. If you think about it this way, tricycle has 3 wheels. So a trinomial has a it is a 3-term polynomial. X squared minus 10x plus 21. So your 3 terms are x squared, -10x, and a positive 21. Another one, 5x minus 4y plus 10. So in a trinomial, you'll have 3 terms, but you'll have 2 signs separating them. Addition, subtraction, whatever. It could be all adding, all subtracting, or a mixture of both. That doesn't matter. So remember, terms are separated by addition and subtraction. Next up, we have 2 of these degree definitions. We have a degree of a monomial first. So if it's a degree of a monomial, you know we're going to be doing something with a one-term polynomial. Technically, it's going to be the sum of the exponents. So when we talk about the degree of something, if it's a monomial, there's going to be one term. But then we also have degree of a polynomial, which is coming up. What you're going to want to do there is you're going to add the exponents in one term. So here's here is my monomial, negative 8x to the third, y to the second, z to the fourth. So the degree of this term, specifically monomial, is 3 plus 2 plus 4. So this is a 9th degree monomial. And our examples, once we get going on that, we're going to be doing this. Some of the exponents in one term. Next up. That's why I said you're going to want to hit pause because I'm going to be going through these fast. Next up, degree of a polynomial. So what this is, it's the greatest degree of its terms. So that says example right there. So this is just an example of a two-term polynomial, technically a binomial, 9j plus j to the sixth. Well, if it's the greatest degree, what you're looking for is really the greatest exponent. So no matter how many terms it has, if you want the degree of a polynomial, just look for the highest exponent. And that is going to be the degree of that polynomial. You're not going to add anything. You're just looking literally for the highest power. And that's your degree of a polynomial. The way that you can tell the difference between a degree of a monomial and a degree of a polynomial will only have one term. So that's how you know they're looking for the degree of a monomial, because there's only one term. Here we go, last one. Standard form. Now something is in standard form when you have the highest degree is on the left, decreasing in powers to the right. Example, 4a to the fourth minus a cubed plus 2a. So decreasing in powers from left to right is 4, 3, and that is a power of 1. Okay, so this is the vocab you need to know for polynomials. Hopefully you hit pause quite a few times because I am going to erase it now. Here we go. Polynomials is my favorite. I love this chapter. There is about 9 sections in this chapter, so it's going to be a long chapter. The first part of the chapter is doing one kind of thing, and the second part of the chapter is doing another thing. And this is what I like to call, it's coming full circle. So the first part of the chapter, we're going this way. The second part, we're going right back up to it. It's all pretty cool. It's visual. I think it's fun. I really love polynomials, and I'm excited to get going on this. So here we go. Example 1. We're going to find the degree. So now we're going to practice finding the degree of each monomial. Boy, that looks really weird backwards. Find the degree of each monomial. So now we're looking at one term, and we're going to add all the exponents. So remember, if a variable is there, it's going to have that invisible power of 1. So here we go. 5x to the second. Something you need to know about the degree of a monomial, it only applies to the variables. We're not talking about coefficients. It's only applied to your variables. And also, when it comes to exponents, there's a couple rules that monomials can have. First of all, you cannot have like fractions or decimals for your exponents. You have to have whole numbers. You can't have variable exponents. And you can't have variables in the denominator. So keep those in mind. And I think it's in, yeah, actually, it's in the very, very beginning of 7.1. Okay, so what we're going to do here is we're going to add up these exponents. Remember, you're only looking at variables. Well, there's nothing to add here. So this is going to be a degree of 2. Technically, this is going to be called a second degree monomial. That was pretty nice. So then let's go negative 1/2 xy to the third. So remember, we're just looking at exponents for our variables. If that's there, it matters. So you have to have a power of 1 right here. So you have 1 plus 3. So this is a degree of 4. We're just adding stuff up here. Okay. This might throw you off here. So the degree of -6. Because remember, technically -6 is a monomial. But if we're only finding the degree of a monomial based on its variables with its exponents, there is technically an exponent here with a variable. I could put it as x to the 0, or j to the 0, a to the 0, p to the 0, w to the 0, whatever. And so the degree of -6 is actually 0. If you think about it, we did this last chapter, yeah. Anything to the 0 power is 1. So x to the 0 is 1. So 1 times -6 is -6. So that's how you can see that there's a degree of 0 here. Because that power of 1. Not the power of 1. The power of 0 that equals 1. I think I'm going a little too fast here and mixing up my words quite a bit. So you're just going to add everything up. That's the degree of a monomial. Okay? So if it just said 15, A, B, C, D, E, F, G, H, I, J, then all those variables have a power of 1, add up 1 plus 1 plus 1 plus 1 plus 1, and on and on and on. Okay? All right. Example 2 is going to be classifying. And example 1, when I started calling them second degree monomial, that is going to help us for example 2. So there's a few things we're going to do here. We are going to classify, write it in standard form. So remember, standard form, highest power on the left, decreasing down to the right. Write it in standard form. Identify the degree. There's a few things we're doing here. So classify it, and that's what I mean by classify, is classify it by its number of terms. Write it in standard form, and then identify the degree. So there's 3 things we're looking for in these problems. And we will start off. -3z to the 4th. Okay, so let's classify it. How many terms does this have? And that's just 1. Because remember, this is a product. -3 is being multiplied by z, so this is a monomial. That's our first answer. Maybe I'll do it this way, because there's multiple answers. Write it in standard form. The great thing about standard form and monomials is monomials are already in standard form. So I would just write 3z to the 4th. Oh, that is negative. That's standard form. And identify the degree. So remember, the degree of a monomial is all of the sum of the exponents. And that's just 4. So it's a degree of 4. And those are your answers. If you want to get fancy, you could say -3z to the 4th is a 4th degree monomial. Kind of puts it all together. Let's go. Next problem. 4 plus 5x squared minus x. Okay, so let's classify it. How many terms does this have? 1, 2, 3. So 3 terms, also known as a trinomial. Next, you're going to write it in standard form. So you're going for the highest power on the left down to the lowest power. That's going to be first. So we have 5x to the 2nd. Negative x has to come before 4, because remember, this x technically has a power of 1. So we go minus x, don't forget your signs, to the left, and then last, plus 4. That's why I say constants are always boring. They're constantly boring because they have no power. Powers exist with variables. I mean, yes, technically it has a power of x to the 0 if you want to, but that's constants will always, always, always go at the end, guys. Even for these things, for anything linear, for anything exponential, constants always go at the end. Okay, so that's standard form. Highest power down to its lowest power. Because technically, this is x to the 0. That's x to the 1st, that's x to the 2nd. And you don't have to have all the same powers. This could have been like x to the 7th, x to the 4th, and that's it. As long as they are decreasing, you're going to be good to go. And then identify the degree. So now you have to think, is this a degree of a monomial or degree of a polynomial? Well, if it's a trinomial, it cannot be the degree of a monomial. So now, its degree of a polynomial says you're going to grab your highest power. That is going to be the degree. Well, since it's already in standard form, there it is. So this is a second degree. Degree up to. So if you wanted to get fancy, this is a second degree trinomial. And not so bad. And then last one, let's go 8k plus k to the 9th. Okay, let's classify it by its number of terms. So 1 term, 2 terms. Little trick. The number of signs is 1 less than the terms. I don't know if that helps or not, but it always helped me. So this is a binomial because there's 2 terms. And next thing you're going to do is we're going to put it in standard form. So highest power on the left, lowest power on the right. 9 is definitely higher power than 1. So we're going to go k to the 9th plus 8k. Technically, that's a power of 1. And then last, we have to identify its degree. And since this is a degree of a polynomial, you're just grabbing that highest exponent. That's why I always like to do the degree after I've put it in standard form. So its highest power is 9. So therefore, the degree is 9. That's it. If there was, I remember kids always ask this question, well, what happens if there's like 12 terms? What would that polynomial called? And is it nonagon, dodecagon, decagon? No, dec. I don't remember. But you don't necessarily use those prefixes. You could just call it a 12-term polynomial. Like, if there's a 4-term polynomial, some kids want to go, it's a quadnomial, I think is what they said. I don't know. Anyways, there's no specific name for that, so we would just say a 4-term polynomial, something like that. Although I think it would be fun to use those prefixes for polygons, for polynomials, like nonagon, nonomial. I don't know. That would be kind of fun. So anyways, there you have that. Okay. Moving on. You guys, we do so many fun things with polynomials. Oh. That's it. Oh, okay. So remember, guys, if you have to, like, pull out things that are polynomials, what they're looking for, you have to have whole number exponents. Whole numbers, so positives, 0 and up. 0, 1, 2, 3, 4, 5. No negatives. You cannot have an exponent in your you cannot have an exponent in your power, and you can't have your exponent in the denominator. So those are 3 things you want to look for on whether something is or is not a polynomial. Okay. That's a quick introduction to polynomials. Remember, there was a ton of vocab. My kids, remember, all that vocab is pink. And so starting tomorrow, you're going to have to get those down. But, you know, what you're really getting down is monomial, binomial, trinomial. And the fact that the whole family is called polynomials. That'll be good. All right. Signing off today. That's enough. You guys have a great day. Those of you guys who are in mountains, stay safe, stay warm, stay out of the snow machine's way. Whether it's a loader or a skid steer, just be safe. We'll see you. Have a good one. Be kind.